Myself Shreyas. We will face the figure presentation. And later if AI is Ayurvedic diagnosis system and developed by guidance of Jayapurma, coordinators of Chitramurti. These are my teammates Akash, Sharat and Lata. And we are solving the problem definition.
Just move on. 11/15/2025. Month to date or year has been done?
Our definition. National Ayurvedic diagnosis centers daily practice traditionally it currently getting the Ayurvedic diagnosis depending only one person like assessment creating different system of patient diagnosis. And there are three major addresses of problems accessibility gap, subjective challenges and integration difficulty. Accessibility gap it means limited qualified Ayurvedic practitioners in many regions where various diagnosis treatment of recommendation in patient systems and subjective challenges in Ayurvedic diagnosis depending heavily practitioner and experiences and it is consistent and recommendations of patient systems and it is using a machine learning models integration difficulty it is uses hard to difficulty of an ancient holistic rules and Ayurvedic qualified diagnostic data. Objectives build the ML model. We are building the ML model. We are feeding the lot of information about symptoms doing lot of income database architecture. Database architecture. Design is relevant information on patients data in history of patient data in act of HLPPA, Health Insurance Portability and Accountability Act, and user interface creating institute diagnostic dictionaries of presentation of both traditional Ayurvedic and medical languages and security appliances. It implements HLPPA complement data handling of encryption protocols and
Now I am going to discuss about the recap and improvements of our project. In phase 1 we have done a market analysis and research, and we have known the basic information of Ayurvedic and used the person requirements gathered for Ayurvedic system, and we have searched for technologies which are required for developing our project. And initially the architecture of system was designed based on flowcharts. In phase 2 now we are going to expand the training concept from 5,000 to 50,000 Ayurvedic case studies. We are going to take feedbacks from practitioners or like doctors or students from Ayurvedic institutes. We have increased the data privacy based on HLPPA compliances. HLPPA is a set of rules or instructions which are used to protect the patient's sensitive information. Here we use UIX design, improved UIX designs. We implemented a multi-language support which helps in the patient for the rural language or distant language. System design and architecture. Here we have the main 5 stages: patient input, AI diagnosis, engine, data processing, inference, security, medical output. In a patient input, here we take input from patients such as their names, symptoms, and health report, lifestyle habits. In AI diagnosis, engine, it is an AI engine process which is used to analyze symptoms of a patient and improve the recommendation for the dosage imbalances. Data processing. This is the stage which is used to normalize, encrypt and validate the data and maintain privacy and accuracy before it fed to diagnosis model. Inference security. We have increased to ensure system security through APIs, authentication, encrypted storage, which safeguards sensitivity of medical records of patients. clinical output. The final output delivered detailed reports and added treatment which are required for treatment.
Here is the implementation data. We are taking the Python and random forest for analyzing this product. The step one is create and save data set. What are required for releasing the output? We are one is body type, secondary decision, and so on. Here is diagnosis, and we are create PDF form. It is for converting the data set creation and next is print the data set created successfully from one entity. The step two is load and preprocess data. Here that we can load the data set as it will Ayurvedic diagnosis CSV. It contains minimum of 5,000 data sets. Here the label encoder. This is used to convert the data set into numerical value by the label encoder. For that we can convert the body type, decision trees, so on. It converts, it transforms into data to numerical value. Then it trains the model. We are using the random forest tree for predicting the output, and we are splitting that text data and the train data, and step for evaluating auto performance. We are here while predicting the while training model for prediction. We are classifying that while predict and while test data set to frame and report to make a report.
See, implementation depicts about the complete code, isn't it? It is an incomplete code. Okay, next.
Basics data set code. Please click here.
The code complete backward.
ಇಲ್ಲ ನಮ್ಗೆ ಏನು ಇಂಪಾರ್ಟೆಂಟ್
ಅದನ್ನ ನೀವೇನು ಈಗ ರಿಸಲ್ಟ್ಸ್ ಹಾಕಿದ್ರೆ ಓಕೆ ಫೈನ್ ನೆಕ್ಸ್ಟ್ ರಿಸಲ್ಟ್ ಹಾಕಿದ್ರೆ ಇದು ನಿಮ್ಮ ಡೇಟಾ ಅಲ್ವಾ ದ ಡೇಟಾ ಸೆಟ್ ಇಸ್ ಟೇಕನ್
Here the step one treatment we are using that label encoder. We have converted the text data into numerical data in the label already taken. By this predicted new text, we are generating new prediction by using the data. Then new input data frame, we are predicting by using the data type for decision tree. Just
here you have shown the data set is created right, or the data set created successfully for the model training. What is it SLDP? ಇದೆಲ್ಲ zero ಇದೆಯಲ್ಲ So what is the data set size then? ಎಷ್ಟು data set ನೀವು upload ಮಾಡ್ಬೇಕು? Data set ನ ತಗೋತೀರಾ?
5,000 case study ಮಾಡಿಸಿ.
5 study
5,000 ಈ ನೆಕ್ಸ್ಟ್ ನೀವು ಮಾಡಿದ್ರೆ ಇದು 5,000 ಮಾಡಸ ಡಿಸೀಸ್ಗೆ ಐರನ್ ಬಾಡಿ ಏನಂತಾರೆ ಮತ್ತೆ ಅದೆಲ್ಲ
ready
data set ready ಇದೆಯಾ?
in those
With complete part.
and we are using this type of data set and it will be available.
Just a minute, I will. So this is just one sample. Let's see the validation. So are you doing a recommendation? Recommendation?
ಅದೇ ಡೈರೆಕ್ಟ್ ಶಾಟ್ ಟ್ರೇಡಿಂಗ್
ಇದು ಏನು ಕೊಡುತ್ತೆ ನಿಮಗೆ ಡೈರೆಕ್ಟ್ ಶಾರ್ಟ್
Next major challenges and solution we are
ರೆಕಮೆಂಡೇಶನ್ ಮಾಡ್ಬೋದು
ಅದು ಸೇಮ್
ಅದು ಇದೆ
ಸಿಲೆಕ್ಟೆಡ್ ಕ್ಯಾರೆಕ್ಟರ್ ಒಂದು ಚಿತ್ರ ಕಿಲೋಮೀಟರ್ ಆಯುರ್ವೇದ ನಿಮ್ಮ ಹೋಮ್ ಮೆಡಿಸಿನ್ ಹೋಗೋದು ನಮ್ಮ ಮೆಡಿಸಿನ್ ಆಯುರ್ವೇದ ಯಾವ ಮೆಡಿಸಿನ್ ಬರ್ತಾವೆ ಯಾವ ಮೆಡಿಸಿನ್ ತಗೊಂಡು 100 ಕೊಟ್ಟರೆ
here we will first one first major challenge is limited data set availability. Since there is no cover and Ayurvedic data set, we created a synthetic data set and with the help of research and consultation of experts. And next, complex terminology mapping. Converting complex Ayurvedic terms into the machine readable mapping. Related to designing future and encoding specific clarity symptoms. And next, model overfitting. Our early models were overfitting and worked very only on the training data. And we use a cross validation and visualization technique to enhance normalization. And fourth challenge is UA integration issue. And this the backend and the front-end with this connecting and whether communication errors will appear, and we observed by stream-rate component structure. And future work and express.
What is that string? Where you have shown?
Stream-rate buttons, charts,
String structure.
yeah, and it contains the buttons, navigation style, charts where we can UA integration connect with backend. Next future work and next placement, and the third phase we collecting real user data, real patient data that can be patient can enter the data sets and which symptoms they occur, and model will help the diagnostic predictions and give prescription and suggestions over the Ayurvedic, and integrating a chatbot interface. Here chatbot interact with the patient system easily and enter symptoms and get back to the Ayurvedic suggestions in natural language. Conducting model testing and validation. The model will be tested accurate, larger and more diverse data sets, which is always are accurate, will be more. And validation ensures the AI system provides consistency with the predictions. And implementing deployment through the web platform. And we deploy our project in cloud server, which is the access anytime and high scalability. These are the references we use.
So here, up till now, what work has been done?
Take